Uh, we just 我是应该是 desktop，我是写 Google Desktop，然后呢
Yeah, thank
we
you.
can. Then I just need
Yeah,
to
leave it.
turn on the camera. They should be able to.
Yeah, that should be perfect.
Or we
I think we click the annotation. How to disable this?
oh, there's a cross mark there. Just click on that.
Yeah. Move this one.
Yeah.
And cross that one.
Yes, should be fine.
And you'll be able to see. Yeah.
Yeah.
And can we?
What do we want?
Yeah. That one. We maybe we can if we can annotate the slide somehow. Yeah, we can. Yeah. That would be nice.
Okay.
We got the marker here. Yeah, okay. Cool. Erase. Yeah.
Perfect.
To go?
Yeah.
Yeah, I think.
Lovely. Does the sound work?
Checking right now.
Cool.
Sorry, that's one thing.
Testing, 1, 2, 3. Okay, fantastic. I might just give the first disclaimer slide into this introduction and then we'll go from there. Amazing. Thank you. All right. Hope everyone else pauses a bit after. All right. Thanks everyone for rocking up. Hopefully we'll fill out in a little bit, but we'll get started now. So thanks for coming down to CISA's S&D revision workshop. We'll go through a little bit of what CISA is, what we do, things that we offer, but quickly before we do all that, we'll just start with a quick disclaimer. Everything that we see in the revision workshop today has been to the utmost of ours and our tutors' ability kept in alignment with the curriculum, but it isn't an officially sanctioned event by the University of Melbourne, and therefore we can't guarantee that anything that's on these slides will be represented on the final exam. However, we have done our best to keep it up to date with the current curriculum. So take it as you see it. This will be helpful, but not in a legally binding way. So real quick, this is an example of one of our CISA's revision workshops, but backtracking a little bit, who is CISA? CISA is one of the largest computing societies at the University of Melbourne. For over 2,500 members, we provide services like social events, education events, upskilling events, internship networking nights, revision workshops like this one, and also provide a variety of opportunities through collaborations with other societies and the Faculty of Engineering and IT itself. So here you'll see, I'll just collapse this view real quick for people who are in the meeting. You'll see a link to our link tree, which basically give you access to everything CISA related, notably our Discord, where the slides and recordings from today will be posted later on. The link tree will also give you a way to access our membership options, all completely free. But being a member means that you stay in the loop, you get access to everything that we do for free, including a bunch of free stuff. So that's generally a win-win for everyone. But without further ado, everyone's here for S&D, so we will continue on. Great. So in that case, I'll hand over to Ashley and Harry, who have very graciously given their time to put together the slides for today. Thank you.
Hello everyone. So my name is Ashley. I'm a current tutor of the software modeling and design. So today I'll be presenting with the Harry, hopefully providing some helpful tips for your final exams.
Yeah, maybe just a quick introduction of myself. My name is Harry. I've been tutoring the subject for several semesters, and hopefully we can share some good stuff with you guys. Yeah. And let's get started.
So for today's workshop, these are the things that we will be covering. So in the first 10 minutes, we'll be talking about the use case, which will go through the textual use case and the use case diagram as well. And then we'll spend 50 minutes on the 5 key diagrams on the domain model, design model, as well as the state machine diagram. And then we'll have about 10 minutes break. After that, we'll go through the design principles and the patterns, which is the grasper principle and Gang of 4 patterns. And then in the last 10 minutes, we'll go through the architectural analysis. And then at the very last 10 minutes, if we are open for the question and answer, if we still have time for that. Yeah, so let's get started. Part 1, use case. So for use case, I think everyone should be pretty familiar with all the use cases, but I just wanted to remind you there are 3 different types of use case that we have, which is brief use case, casual use case, and fully dressed use case. So most of the time, I think only brief and casual use case will be appearing in the final exam, just because the fully dressed use case is quite long. We probably don't have enough time for that. So let's start with the brief style use case. So it's pretty straightforward. You just write down the key steps for the problem that been given to you. And we usually expect it to be between 5 to 10 steps. It doesn't need to be very long. And then with the casual style use case, only thing that on top of the brief one is we have an alternative scenario for it. So just make sure that you are familiar with the brief and casual style. So when you are asked to write this down in the exam, you know what to write. Okay, cool. And then here is just a quick example about the fully dressed use case. As you can see, it's quite long, so you probably won't encounter this in the final exam, but it's good to know we also have the fully dressed one. Okay. Now let's talk about the use case diagrams. So it is transformed from the textual use case. Use case diagram shows all use cases in our subsystem and their relationship. And each textual use case only describes one use case. Okay, so here is the use case diagram. So just to remind you, on the for the use case diagram, we have 3 different type of actors. So on our left-hand side, we've got our primary actor, which is usually the end user of our system. And it can be multiple, it can be more than one, but usually it's just between 1 and 2. And then on our right-hand side, we've got our supporting actor and the off-stage actors. So for the supporting actors, it can be a person, but it also can be a system or service. So like in this example, it's an inventory management system as a supporting actor. Yeah. And then for the off-stage actor, it's good to know about it. For the offstage actor, you're usually thinking about organization that is influence the system, but not directly interact with the system. The most classic example will be the tax agency. Because all the design systems that you develop, it needs to match it needs to follow the regularization, but they don't really interact with your system. Okay, and then inside the use case diagram, we can see there's each little bubbles. So each bubble represents one use case. So you're thinking of feature level rather than in very much detail, because during the workshops, we commonly see students write things like click into the button. That's not considered to be a use case. We are thinking about feature level. Okay. And then on the use case diagram, we can see there's also this extent and include notation. So we just want to really quickly go through this. So for include, it's usually for reduce the repetition. And then the sub cases always execute. So you can think of it's a mandatory behavior. So for example, if you look at this one specifically, for the buy now and checkout cart, there's shipping and payment as included one, because no matter which one you go, it's mandatory for you to go with the shipping and payment. Okay. And then next we've got our extend notation. So base use case is complete on its own. Extension as optional behavior executed only under certain conditions. So if we go back in here, so in here we've got search products. It extends the advanced search. So you can think of when you're trying to search something on an online website, like it's mandatory for you to type in the name, but sometimes you can do the advanced search with like a filter on the size or the color, but that's always optional. So in simple words, include is mandatory and then extend is optional. So that's probably the quickest way to remember the difference between these two. Okay. So that's all about the use case. And then we would like to ask everyone to try to attempt on this exam style question. Yeah, so I'll just give you about 2 minutes. Yeah, to read through the question so we can work on it together. So so the first question we'll be doing is writing down the use case, placing in order.
Shall we go through the answer?
Have you read through the question? Are you trying to writing it down? Yeah.
Maybe another 1 to 2 minutes,
Yeah.
and then we'll go through the answer.
Yeah.
Yeah.
Okay. They still working on it.
Yes.
It's probably a long. Shall we have a look at the answer together? Yeah. So what we're gonna do is we're gonna go straight into the answer. So yeah, so that's the main success scenario. So for the brief style textual use case. So something like just wanted to share some tips with like writing the textual use case. So first thing I think it will be really good to identify is always the system itself, the system under discussion. And then the second thing I think it's really important is to identify the primary actor. So that's always like, two first thing you should do. And after that, I think it will be useful to highlight the sentence that start with the verb, which is like, the actions. So that's usually like, your step-by-step textual use cases. So this one starting with like, the primary actor customer, select verb, select their desired coffee from the menu using the app, which is the system that under discussion. Okay. And then second thing is the system will prompt up the customer to customize their drink. But here it mentioned like it's an optional behavior, like customer can choose to do it. So you can use the extend notation here. And then next, the customer, primary actor again, select verb, have it here or take away option for their order. And then next is the system calculates the total price. See again the verb here, present all line item details and payment options. And then fifth step, customer enters their payment details, which the system validates and records in here because it's mandatory for like this use case. So you can see the include notation is here. And then the system records the order and updates the queue for baristas. And then the system notifies the customer when the order is ready. And then customer receive a receipt from the system, pick up their coffee and enjoys it. So you can see the pattern. It's either starting with the primary actor or the system itself, and then it's the verb, which is the actions. Okay. And then here we'll be talking about the alternative scenarios. So this will be something that, something went wrong during the main success scenario. And then there's some alternative scenario here. So it has like many different alternative scenarios. So as long as your your alternative scenario is making sense, it will be acceptable. And it also needs to be linked to your main success scenario as well. So you can't have like an alternative scenario that's totally not relevant to your main success scenario. That doesn't make sense, right? Yeah, so I think that's it for the textual use case part. And then we would like everyone to attempt on drawing the use case diagram as well. So we'll go back to the main success scenario, and then we can derive the use case diagram from there. Should be pretty straightforward. I feel like each step would be like a bubble.
Yeah. Maybe I'll add a few extra tips for writing a use case. So you can tell from the main success scenario here, we have 8 steps. If you're gonna do a good use case, it's very likely you're gonna be between 5 to 10 steps. So you're gonna aim between 5 to 10 steps for each for each use case. And for each sentence, there should be around 15 words, right? And the key idea here is the step should be really descriptive, right? So you go for like the customer select the desired coffee from the menu using the app. You don't go something like the customer select something. The customers click on the menu, that will be too detailed, and you don't go super high level. So each step should be it should include the right amount of detail. Should be between maybe 10 to 15 words, and they should be descriptive. Similar idea for the alternate scenario. For alternate scenario, we can use it to model 2 things. One is failure situation. So one example would be an online payment has failed, right? So you can model, you can use alternative scenario to model failure situation or another flow, right? So maybe here we have another example. At step 8, when customer receive the receipt from the system and when they pick up their coffee, and what if they spill their drink immediately? So that's an alternative flow. You can use alternate scenario to model that as well, right? Not only failure situations. right? And then let's attempt to draw the use case diagram, right?
Okay, let's go back to the
Oh.
main success. This one should be this one, right?
We can draw the for the whole system. For the
It's okay.
yeah, let's just put
But maybe it's easier for them. Oh, sorry. Here, hold on. Here,
just let them.
okay. Draw from here. Okay,
Yeah.
sure.
Yeah.
Oh,
Yep. Same scenario. We'll just skip the reading time and we draw the use case diagram. Right.
does anyone want to attempt on the board?
Yeah.
And anyone wanted to do the guard?
Yes.
As long as
No, I
you do
don't.
that.
I'll let you know if.
You don't have a go. I'll make the soon comes up. So.
You want to have a guard? Here we go, here we go. So we have some chance to give you some advice.
Could extend the difference.
That's
Yeah, we'll go to that. So include is mandatory, extend is optional. So just think about that. It's probably the easiest way to remember that.
So focus on the second paragraph. When you read through the paragraph, you identify different use cases and you put each use case as a bubble on the diagram. Yeah. Yeah. So place in order is a use case we just identified. So that's definitely going to be a use case on the diagram. But
My copy, but not really sure. The
yeah.
include
That's right. We can model that later. Yeah. Yeah. Nice.
second
Yeah. Supporting access, yes. Yeah. What other actors would have for this system?
the stuff, but
Yeah, the barista.
Is this usually a system or is it a person?
It's usually not a person.
It's a system. So it's like this is like the ordering system.
Yeah,
So it's like
the ordering system.
Ordering system is probably the system.
yeah.
Yeah,
Okay.
So something else.
maybe let me go through the answer with that.
Yeah, but you're doing great.
Yeah.
You've got most of it. And then, yeah, so, yes, I was gonna say.
It's my coffee and buildings for be notified this way.
Yeah.
And this whoever it is notified.
Yeah.
Yes.
And then I usually suggest you to add the system in the discussion, very top of the diagram, remember? So that you don't forget about what's the actual system and the discussion. Yeah, so that's the,
Yeah, smart coffee system. Or we can call it
big body, that's. the-
Okay. Right.
The name is actually there. That's it.
Yeah, let me take over from here.
Thank you.
We can always discuss about the first step is definitely to identify the system under discussion. Right? So here you have the beam body, which is our SUD, right? And then you identify the actors. Here we have the customer, and we have a barista as well. So you can draw another little human figure here, and that's our barista. Right. Now when you read through the sentence, right? When a customer, the customer is able to place an order, the self-service mobile app, and that will be placing an order, right? And then the customer may choose to customize their coffee. So customer may choose, and then that's an optional case, right? So we can have customized coffee as a separate use case, but that can be an extended from here, right? So we can choose to customize their coffee or not, and this customized coffee can be a separate use case because there can be many steps involved here, and you can write a whole use case for this sub cases. We want this to extend the base cases, and then you can choose have it here one click away, and this will be too detailed to put in the use case diagram. The system should be able to handle payments. To handle payments can be another use case, or like if you argue handle payments can involve many steps and it can be a complicated process. So we can go and handle payments here. So handle payments. Let's imagine if your InBody app can handle food ordering in the future, and that will include handle payment as well. But this will be a include rather than a extend, because whenever you're placing an order, you have to pay, or you can't pay, you can't leave with the coffee without pay. So here we have to use include here, right? That's our base case place an order, and you've got an extend cases, which is customize their coffee and handle payments as an included sub case. Then let's move on from here. Barista should be able to view incoming order and prepare them. So we got our another active barista here. Right? We got our barista here. And barista essentially will connect to first place an order, because when customer place an order, the system will notify the barista as well. The barista will connect to this as well. Right? And customer should be notified when order is ready. So you got a notification as a separate use case, and that will connect to the customer. So that's good. And if customers spill their drink immediately after pickup and post it on social media, they should receive an option for a coffee credit replacement, right? Then there'll be a separate use case of coffee credit replacement, right? And this will connect to our customer. So, okay. Below incoming order, this will not connect to the customer, right? Because the customer will not be a primary actor for this use case. It will be connected to the barista. Will be the barista who will the incoming order. Right. And I think that's pretty much it. Customer should be able to leave feedback can be another use case here. But that's the primary idea. When something is optional and it complements the base case, you use extend. And when something is on the way for you to achieve a base case, then you use include. Right. Any questions? If anybody online has any questions, feel free to unmute and stop us.
Wanted to quickly something. So in your use case diagram, I think it's really important to think about the order of doing that. So very first, always draw this little big square that you have. Second thing you do is identify what's the system under discussion. And then the third step will be thinking about the primary actors we have on your left. Then in that case, you've got a bit of mark already. And then next thing we do is looking at the bubbles we have. We're aiming about similar to your steps, like 5 to 8. 5 to 8 steps, textual use case, similar in the bubbles as well. And after you've done that, you can then think about the supporting actors in here. So we've got the bubbles here. And the very last step, you think about the supporting actors. And then very lastly, if you have time, work on the extend or the include. But the main thing is about drawing all the other parts correctly. Okay. So that should be the helpful tips for you to draw the use case diagram. Yes.
Yep. Yeah, let's move on.
Let's move on. Okay. Oh, where's
So we just repeat the point on the extend and include the difference again. For the extend include, I can't forget.
You mean for extending?
How to tell when to use extend versus include?
Oh, include is something mandatory. Like, so if you are checkout or doing something like that, it's mandatory for you to pay. And then for shipment, so that's mandatory include. And then for extend, it's optional. So it's something user choose to do, but they can also choose not to do. So it's just about mandatory and optional.
So it's like mandatory and not even optional to specify.
Yeah.
Yes.
So, some good example would be, you sometimes have the promotion code. When you place an order, you can enter a promotion code, and that will be modeled as extend, right? Yeah.
Yeah, and then just these are the real quick summary. So by the end of use case part, you should know all of that. For the textual use case, know the styles, know that there should be 5 to 8 steps. And then for use case diagram, is each bubble representing one use case. Actor types, you've got primary, supporting, and offstage. And then lastly, the relationship, you know the difference between include and extend. As I said, mandatory and versus optional. Okay, let's continue. You want a photo of that? I'll let you take a photo. Yeah, and then next bit, we will talk about the 5 key diagrams that we have. Yeah, so for the 5 diagrams, we will divide it into problem space and solution space. So on the left-hand side, we've got the problem space, which it's also the domain model. So it should have no technical or coding details. And then second thing is it can show the inheritance. And then what it does is it shows the semantic relationship between the concepts. And it's unidirectional. And then on our right-hand side, we've got the solution space, which is our design model. Compared to the domain model, it includes the technical and coding details. And remember, it strictly maps to your source code. So it should be matching your code. And then lastly, it defines formal classes and associations instead of just the semantic relationships. So both domain and design models include static and dynamic modeling. So for static modeling, we are talking about the class diagrams. So for the domain, it's domain class diagram. For design, it's design class diagram. And then for the dynamic modeling, it's the sequence diagram we're talking about. So for domain, it will be the system sequence diagram. And then for the design, it will be design sequence diagram. So it's very important for you to understand the difference between these 4 diagrams, so you know which one to draw on. Okay, is there anything you want to add on? Okay, let's go through the first one. So which is the domain class diagram. It's one of the static model. So its purpose is to show the key concepts and the relationships in the problem space. And then key elements we are looking for in this diagram is the classes, which contains the name, as well as the attributes. And then we are also looking for the labeled associations, which is here. And then we are also looking at the multiplicities. Okay, so these are the things we're looking for. And then we can also be looking at the inheritance, but remember it's inheritance only. We shouldn't be seeing anything like, interfaces or implementations, things like that, okay? Now let's have a look at this domain class diagram together. Can anyone tell me what's wrong with the diagram below?
Domain class diagram.
Yes. Any attempts? People on Zoom? Yeah, no privacy modifier. Oh, we've got a great answer from Erica on Zoom. Show the answer. Yeah, so visibility modifiers, I think mentioned the data type,
Yeah.
methods, direction. Yes, good point to mention about direction. And we have a bit more, little bit more. What's missing in the diagram? There's something that's incorrect, but is there something missing? Yes, correct. Oh, great, Erica. Yes. Okay, let's have a look at the things together. Few things that we already discussed: no visibility modifiers, no data type, should be no method, and then there should be no directed arrow in the domain class diagram. And then it's missing the multiplicity. Yeah, and then the very last thing I think the one mentioned is that there shouldn't be logger class here, because logger is more of like a software concept, like it wouldn't appear in the domain modeling. So that's something you need to be aware of. Okay. Cool. Now let's have a look on the design class diagram. So the purpose is to show the software level classes and the relationships in the solution space. So the key elements we are looking for are the classes, same thing, but now some of the classes will come with the indicators. So for example, like the extra and interface indicators. But again, these should not appear in your domain model, but should be in the design model, okay? So you should have attributes with the visibility modifier, with the data type as well. And then you should also have the label association. However, in this one, you also have the directed association as well. So remember that. Same thing, we have the multiplicity. That's something we're looking for as always. I might just close this. And then we also have the dependency as well. But it is optional. It's not mandatory to do it. So dependency is like composition or aggregation. So these are the things we're looking at as well. And then lastly, you've got the inheritance, same as before, but you also have the interface as well. So you can see those on this little diagram below. So now let's do a quick revision on the notations of the design class diagram. So up there, top left, you've got the private, public, protected, which is the visibility modifier. And then here we also below, we've got the different association lines. We've got association with direction, and we've got the arrows for the inheritance. And then we've got the implementation and realization, which is interfaces. Remember, it's with the dashed line. And then very lastly, we've got the composition and aggregation as well.
Yeah, sure. One thing to know is that if the question is not asking about composition or aggregation, you don't need to draw them unless the question specifically calls you to do so. Here is where more we test you on the concept instead of drawing composition and aggregation. So here the aggregation, if we let me spread the bucket here. If we're gonna draw a Venn diagram, this right, we have association on the layer, and then you have aggregation, and then you have so here, according to the Venn diagram, they're all subset of association. So there are special cases of association. The difference is this will be model ownership, right? So the model ownership. So when you want to emphasize, or when the question asks you to model ownership, then you go aggregation or composition. The difference between these two is aggregation model a weaker ownership. So if we remove the whole or the system parts, the smaller parts can still be can still exist on their own. For composition, if we remove the bigger parts or the system, the individual component will not exist on their own, right? So they are dependent. For aggregation, they are somehow independent, right? But you still imply a independent relation should be here. Yeah.
Okay, thanks, Harry. And then we'll keep going on the associations. So I think with the association, we just on the right hand side, we wanted to show you how the association is represented, like in the diagram and the versus the code. So with the association, if it's directed association, that means like one class containing an attribute of the other class. And then with the association with no direction, it means they contains each other. And then in this one, it's a one-to-one relationship. So that means they only contain like a single attribute. Okay. And then the next line, we've got the association with many-to-many relationship. So that usually means it's either like a list or an array list of the attributes, or like a collection of the attributes. So it's more than one. Okay, so this is how you should think about this when you join the association and the multiplicities. Okay, cool. Okay, let's do a quick one about this design class diagram. So what's wrong with the diagram below? Can anyone tell me?
We're seeing triple diamonds and arrows now.
Yes, correct.
There's no super.
Yes, correct. Both correct. So first one is the direction of the arrow is incorrect. It should be other way around, because for an item to have a person, that doesn't really make sense, right? It should be vice versa. It should be person having the item. Second thing is missing the visibility modifiers. Anything else? Yes.
Variable name for the language should have string next to name.
Yeah. Data type. Yes, correct. Excellent. Yes. Anything else? Few more. Missing something? Are we missing something in the diagram? Yes, correct. Excellent. We are missing multiplicity. What else? I think that's about it. Did we mention about the methods? Let's have a look at the answers together. Yeah, so visibility modifiers, data type. And then in here, I think it also it has success. It's probably an incorrect method return parameter as well. It's either void or a data type you define, and then we don't have such a thing in here as well. Okay, and then missing the multiplicity as well. So it's really important for you to include everything for the design class diagram, because we'll be looking for these things. Okay, cool. Now let's jump into the system sequence diagram, which is the SSD. So the purpose of this diagram is captures the interaction between the actors and the system. So in this diagram, we view the system as a black box, and it's in the problem space again. Okay. And then the key elements we'll be looking for in this diagram will be the actors as well. We can have multiple actors again. And then the second thing we'll be looking for is the system, and there should be only one. And then third thing we'll be looking at is the messages, which is lines between the actor and the system, but it needs to be in the correct sequence. So it needs to be in the correct order, okay? So have a look at this, these are the actors. On the top left, it's with the little human figure. And then on the right-hand side, we've got this system. It's a little box that you have. So remember about this notation. And then you've got the lines here and there. describing the steps. So when drawing these, make sure it's in the correct order. And then another thing we wanted to remind you is that this diagram is about the interactions between the actors and the system. So we don't really care about what's going on between the actor and the actor. So see how in here you've got the driver and customer, but there's actually no lines between them because we're designing the software. We don't really care about what's going on between the actors, the humans. Okay, so this is something you need to be aware of because we often see people drawing lines between two actors, but we are not asking for those. Okay, just be aware of that. Cool. And then the next thing we'll be talking about is the design sequence diagram, which is the DSD. So it's in the solution space, and again, the purpose is to capture the interactions among the object classes. Now, this time we are not treating the system as a black box. We are going inside the systems. We're really looking at the classes you have in your code. And then the key elements we're looking for, first thing is the trigger core, which is something here. And then we are looking for the object classes involved in the interaction. Like class 1, you should have the actual name. Class 2, these are the object classes we're looking at. And then we're also looking for the method calls between objects, shown in the correct, again, execution order. We're also looking for live bar, but that's kind of optional. If you're confident you can draw it correctly, yes, go for it. But if you feel like there's not enough time, you can kind of ignore it. Don't spend too much time on the live bar. Okay. And then in here, if you look at this clear method, so it's a self core. So again, I wanted to remind you that when you have a self core, that means this method is located in this class. Okay, and then when you have a do be that's pointing towards class 2, that means this method is in the class 2. So this, if you are given a piece of code and then drawing the diagram, you should be aware of those. So that will help you to draw the diagram quicker. Cool. Okay. Hope that's clear. Is any questions? Oh, attribute name. Perfect. Okay, now let's have a look at this design sequence diagram. Can anyone tell me what's wrong with the diagram below? No, sorry?
One thing was the software method.
I didn't.
Oh wait, this is design.
Design, yeah. Not, yeah, it's a design. So recall, this is a design sequence diagram. I think we've got some method. No actors, correct. Yes, yes, that's a good one. That's a good one. Yeah. Did you say something as well? I didn't.
You said the return should be document.
Yes, correct. So yes, that's the two mistake of this diagram. First thing is Erica mentioned, which it shouldn't start with a little human figure. It should just with an initial method call, and it's definitely correct as well. So it should be the return dash line. Yes. So these are the two mistake. And then I think one of the question we often get asked is about how should we draw the return line, because we've been seeing different notations. So there's actually two options for you to do this in the design sequence diagram. Option 1 is have the get name and then have a dash return to return that variable. We also have a second option here, whereas you just have name equals get name with one line. So you do have two options. It's up to you which one you want to go for. But in general, we'd recommend the option 2, just because design sequence diagram is a very long and complex diagram. When you can, it will be good to trying to reduce the complexity of the diagram so it's clear, nice and clear. Okay. Cool.
Message in the chat.
Yes.
Yeah.
Trigger call.
Yeah.
Yes, correct. It should be a trigger call. Yes.
Yeah, I got another question for you guys. So how many class diagrams do you draw for a scenario or for a case study? How many class diagrams do you want to draw? Anybody knows? And any idea? Any idea? How many class diagram? Any like for domain class or even design class diagram? How many do you draw for a scenario? The answer is only
Is it a bit like dependent on how many like scenario that like multiple systems then? Or like,
Maybe one in the domain, one distribution.
Alright, so the answer is you draw one class diagram for the entire scenario. But what you mentioned is meaning the sequence diagram. So you can draw as many sequence diagram as you want. For the system sequence, we just think you model the relationship between actors and the system under discussion. And essentially you're trying to visualize the use case. And you can have many use cases for a scenario. So you can draw many SSD. For a design sequence, you're trying to visualize what's going on with the method. So after a trigger call, after a initial method call, what will happen in your code base within your system. And you can do this for so many methods in your application. And so you can draw as many as you like. But you only draw one class diagram for the entire scenario because class diagram need to model what entities do you have and their relationship. And sequence diagram need to model the logic flow. So there can be many sequence diagrams.
Yes.
Yeah.
Yes.
is that a question about like the last bars?
Mhm.
When you draw them, are you drawing it like down to like the max amount of time it can go to? Because I was like in the science, the last one, it's like, yeah, I had a moment where you could end the turn and but you could also keep going. So it's like, where do you finish the life bar in that case if you have like a
Yeah. So the idea for a live for a live bar is it will span for the entire runtime of a method.
right?
Right.
Yeah.
So here you do A and then that's a method, and you do a bunch of other stuff here. You call a method called clear, you call do B, do C, do D, and all these methods are called in the body parts of do A. So if you're going to look at the code in the method do A, if you look at the code, right, there will be method calling different methods. There will be method calling do B, do C, and do D. And so they're all in the body parts of the do A method. And as long as this method runs the entire runtime, right, you will have that lifespan there. Does that answer your question?
Yeah, a little bit. It's just
If you have a different flow, so you can have thread like optional thread or the alternative thread. Having that, you still have the lifespan. So imagine how can implement that in your code. You have if else.
Yeah.
If scenario one, you do something. Else you do something else.
it would just go to the
Yeah, but it's still in the runtime of that method. Right, so the stack is not clear and still within that lifespan. So you draw the activation bar all the way down until the method plan or until you return something from the method.
Okay, let's move on. Cool. And now it's time. I think we'll continue with this example, and then we just wanted everyone to give it a go on drawing the domain class diagram.
Yeah, same case study, but this time we draw a domain class.
Yes.
Yeah. And we want to attempt this in maybe 3 minutes.
3 minutes,
Yeah.
yes. Yeah, we would appreciate some volunteer as well. If someone wanted to draw on the board. Okay, so or you wanted to have, well, let's have a fair go. You can do that. Thank you. And then a really good tip for this diagram as well is when you're drawing a domain class diagram, it's best thing you can do is to write down a list of nouns appear in the question, because that will be your classes. Yeah.
Yeah.
So that's something we always do if you get confused on what to draw. So for example, in this one, if we have a look together, I'll probably have a look at the customers. Yes,
Oh.
customers as a noun.
Lost. Yeah. How do you?
I think drawing like that, you just do it in the line, beneath the customer. What do you think? You wanna highlight?
Okay, sure.
Yeah.
I'm just trying to figure out how to Yeah. How do you
Yeah, clear.
clear?
Yeah.
I want to use this one. Hang on a sec. Delete that. Keep staying here. Put it there. And we delete that. You can keep going. I'll just follow you.
So what we can do is that we can have a look at the customers. That'll be the first thing.
Yeah.
I'll circle it up. Yeah, the next thing I'll be looking at probably is the order. Yes. Self-service mobile app maybe or maybe not.
Yeah.
Depends.
Let's
move on.
let's leave that. Yeah.
Leave that.
Yeah.
Maybe or maybe not. And then customers may choose to customize their coffee.
Yeah.
Coffee. I think that will be an important thing. And then if you're looking at the bracket, you're probably thinking about maybe these could be your attributes
Yeah.
that you're looking at.
So whenever you identify a noun, it can be either a class or the attribute within the class. And you're going to figure out whether it's a class or an attribute, right?
Yes.
Yeah.
Yeah, and then choose to have it here or take away, or that could be like attributes
Yeah.
that you have.
That's right.
Yeah.
Take away. I'll just use this. Yeah.
Different lines.
Yeah.
Yes, that's good. System should be able to handle payments.
Payments.
Maybe it could be or not, and
Yeah.
we have cash, card, or digital wallets.
And that's definitely your different options, different properties of a. Oh God.
That's
I'm sorry about this. It's just. Yeah.
We have the barrister, we can have that. For
Yeah.
sure. No, and then we'll keep going, view incoming order.
So we've got order here. Yeah.
Efficiently, customers should be notified when they are notified. It's a
Although it's a verb, but
Yeah,
you can
yeah.
have it as a as a class. Yeah.
yes. If a customer spill the drink immediately after pickup, drink.
Yeah.
Maybe
I mean,
not,
yeah.
because it's
Maybe let's do a question mark here, right? The question mark. Okay.
Yeah. Pick up and post it. So that could be an attribute
Yeah.
we're looking at, because these are the ways you can collect your
Yeah.
order. Yeah, post it. They should receive an option for coffee tragedy replacement. Yeah, yes. That.
Right. Another concept, and this is likely our class. Right?
Yeah. And then customers should be able to leave
Feedback.
Feedback could be something.
Yeah.
Yeah. What they thought about coffee and barista. Yeah, I think we
Yeah.
cover most of the nouns.
Yeah.
Yeah, so yeah, make sure with those, like you've identified as nouns, make sure you cover all those classes. Because during the exam, it's really important for you to cover all the key classes.
Yeah.
If you're missing one, that will be considered a major loss on the mark, because with missing one class, you're missing a few multiplicity, you're missing a few association lines,
Yeah.
and then you're missing that class and the attributes. So that's a big lose. So you want to avoid missing any key concept class.
Yeah,
That's
sure.
something you want to be aware of. Yes. Do we have some chat? Will short while one short. Wow.
Yeah.
Yes.
A good trick for doing the domain class, if you're not sure about whether something is attribute or class, just draw a class, right? And it's better to have it more instead of less.
It's really important to not miss like one key
Yeah.
conceptual class.
For the payment type.
Just so we can let, we just stop sharing it now, so.
Yep. Sure.
Oh, you want that page or?
I don't mind.
Yeah.
If you guys want to chime in now.
Yeah, first up, just.
Awesome.
Order.
We've got the customer tick, coffee tick.
Over, yeah, nice.
We've got order, yeah, tick.
And order tab is essentially have it here or takeaway, right? Have the payments, lovely. The payment method and barista, right?
So we maybe want to add the barista. Yes.
and barista back to order. They want to see the orders and let's imagine barista would able to see certain orders, and each order can be served, let's assume more than one barista, it will be one thing. But at least one.
Yeah.
And we want labels on those associations, but yeah, it's fine. And what we have here, the customer should be notified, so we can have a class called notification. This is a domain class.
Probably by the bullet points, but it's confusion.
I'll say that we're meant to be.
Notification will connect to order and turn to classes. Soon, all those are and order, so in notification only belongs one order and one order, that's 50% on one notification. And this will be sent to one customer, so one customer can receive many notifications. And what else do we have? We have a group here. The group has been labeled as question mark. Drink technically can be enough, but we want a config here. One possible option is we can do a drink class here. But we can have it as a generalization or specialization. Right, so imagine in the future you can have other than coffee, and you have something else there.
Yes.
So that's one possible way, but that's all. And what else? We have the feedback and coffee tragedy replacement. Coffee and replacement. Right, and that's pretty good. That's fine. Yeah.
Using the label association.
Label, yeah, we definitely want more label.
So make sure, we not gonna write all, but please don't forget to write down the label association, because that's a really important part. Yeah. So, yeah, so you already see the techniques we do. First thing, highlight all the nouns that appear in your questions.
Yeah.
And then make sure you cover all the key classes from that list of nouns. And then next thing is do your association lines, do the multiplicity and write on the label as well. Please don't forget about that. Yes. I think that's it. Any questions?
Any questions for Colin?
The reason that you say that we can use the generalization is because coffee has more attributes. So it's like that would be like the parent class. Whereas the top one payment is just like just the type itself. So that doesn't need to be like generalization specialization. But specialization for the cash card is definitely happening.
I mean, there can be some common problem for drink. We can sort each drink size and the size, right? And that there can be more here in the drink, so you want them to include it in the whole company. That's good. All good? Yeah. Okay.
Any more questions? No? Cool. Let's continue. Oh, so here is our sample solution. So we like to share with everyone. So in this one that we've got the drink as well as we discussed, because in the future we can think about the extensions or upgrade on the system, whereas we don't just have coffee, we can have juice, we can have water, different stuffs. I think that's basically everything. We've got pretty much.
Yeah, so we're just missing the feedback and that's it.
We're just missing one feedback, and I think we should definitely include that. Okay, cool. But pretty much I think we covered everything. Okay, let's continue. Yeah, of course. Yeah, sure, of course. So just after this or?
We let's maybe go through the next.
Just one more
Okay.
question because it's the same,
Yeah.
like, same question. Now, we would like everyone to attempt on drawing the system sequence diagram.
Yeah.
For placing an order.
Yeah.
So
And be mindful that's a system sequence, not a design sequence.
yeah, so make sure that you draw the correct diagram.
And you draw that specifically for placing an order, right? For a use case. Any volunteer?
Yeah. Thank you.
Oh, we'll pull out the use case. Have a look. The use case. Yeah.
With this one, since we've got like, the use case with the correct order, or I think it will be helpful.
Yeah.
Like, to draw the system sequence diagram. And then a great tip on this is remember, first thing is
It's actually the part that I
identify the
don't read
actor,
it.
second thing
So-
is you identify the system. And then you do from there. You can do it again.
Presentation.
Yes. So now what we start with,
Okay.
first thing is we have the system.
Yeah.
We treat it as black box. So what do you always draw the system? Yes. On the left hand side, I've got the primary actor. That's name.
Let's call it.
What's the
Customer.
Customer, yes.
Yeah.
Right. And then how many actors do we have in this one? What do we think? Can we have more than just one for this example?
Is there any other actors?
Any barista, yes, yes,
I want to draw the barista.
yes.
Same.
Next to it, that's fine.
It will be better if we draw the barista on that side, because possible will be of primary actors.
Yeah.
Yeah.
And then the barista is secondary, so it's not that.
No, it's like the second part.
Yeah.
Because the system interact with more with the customer rather than barista, right?
We draw the barista here, yeah. And we want to draw the SUV, which is spin body next door actor.
Right, right. That we've got that's on right is our system.
Yep.
Remember? System.
Okay.
Yeah.
So it's a
Spin
B,
body,
right?
Yes.
and we want to draw the box there. Nice.
Nice.
And then you follow the steps from your use case.
You're already halfway to your success because now you have the left hand side with the primary actors and then you've got the right hand side with the system. So 50% of mark earned. Let's draw a line.
Right.
You can look at the use case here.
Yeah, so what's the first step?
So the customer says they're deciding how.
Yeah,
Yes.
yeah.
Alright,
So select a topic.
And then the system
System
call
of the customer to classify their print. Do you have a dash dot next? Yeah. that's-
customer says have here to do.
So choose other option.
Yes.
System complexity. Sense. Great.
Yeah.
Yeah.
We verify.
Customer enters their payment details, which the system nowadays, of course.
Yeah.
So enter the payment details.
Yes, good, excellent.
What we can optionally do here is let's imagine we have.
Oh, is it like this?
Yeah,
Oh,
it's
okay.
a supporting actor. So you have a payment agency, that's where third party or external actors, and you have this line here, right? But this one actor, this is not a class, that's the actor on the side. You can come here and look, verify pay detail. I'll see what was the start of pay detail, right? Then turn it here. Test, right? And then we have the system order, the system record order and update the queue first, so.
So now this thing.
Well,
Yeah, or this thing.
good,
So.
yeah. But we have a tricky thing here, and a really subtle. Really subtle syntax. You know, this is the system sending request to something else, right? And when something is an input, will be solid up. Okay, so here, one has to be solid. This is update.
Oh, cause this is like. Input not return.
Yeah, it is some returning. Some returning.
Systems.
So the system,
Because it requires the other and updates the queues like this stuff. So it's not returning, it just updates for this free stuff. So it says dash line.
yeah. Yeah.
Yep.
Figure out, then all the. Right, and then the next step is the system notify the customer when the order is ready. Right? So when the order is ready, you don't care how the system prepared the order, but you care the interaction between actors and the system. Here, after the order has been prepared, send it back to you. Optionally, you can have one additional step here. When Marissa finished the order, set a message to the system, and then the system send a message to the customer. We can have that as well. Yeah.
And then, yeah, I just wanna share like, tips once again. So, as always, because we know the SSD is creating the system as black box. So always first thing, draw a little square here, and then draw the lines. And then second thing, identify the primary actor. If you have any additional primary actor, that's all says, okay, you draw. And then you start from there, and it's usually starting with, like, it's just the lines between the primary actor and the system, like back and forward. Sometimes it will, involve the second, like, primary actor. That's very straightforward. And then when you have the lines ready, all you're doing is looking at your like problem, your question, and then do it like by the order of this time. So it's very straightforward. So yeah, third thing is just drawing these, follow the text. And then if you have spare time, you can think about this part, but like optional, it'll be nice to have, but if you have limited time, leave that, just do this part that will, earn most of mark for. So that will be the tip on the system sequence diagram. Yeah. Oh, I think that's it for the path diagram, and then we'll just have our break as we discussed.
Okay,
Yeah.
so we might just have a 4 or 5 minute break. And yeah, everyone please are free. We've got drinks at the very back, got chips, and all description, and more than we know what to do with. So please feel free to take more than one.
All right, guys, let's get back on track. Yeah. Let's go to placement here. Placing an order. We've done all of that, yes. And then we move on to, yeah, that's the answer for our SSD. We got a loop from here, and you got different actors and different supporting actors and your system. We're not going to let you draw the design class the design class diagram, but we can have a look of the design class. Mainly, you have something similar to a domain class, right? You have something similar to a domain class, but what's the difference here is you have many additional classes. Like you have a controller to handle the input or the request from the UI, right? And you have different indirection or pure fabricated classes, which actually we'll go over when we talk about the grasp. Here is just a basic idea. Next we have the state machine, right? The state machine mainly will be tested for the diagrams. And when do you use a state machine? You can tell you want to use a state machine when you want to model a system that have different behaviors according to different conditions, right? So if we read the definition here, it shows how an object can change its state in response to different events within the system itself, right? We have three key components for a state machine. The first one is the state itself. So every bubble, or sometimes it's a square you saw in the state machine diagram, is a state. And we can have an initial state or starting state, and you can have an end state and a nasty state. For an initial state, how do you denote an initial state? You do this by looking at the initial transition. So there will be an initial transition denoted by a big black dot pointing to one state, and that state will be your initial state. And you have an end state. The end state is optional though. Not every scenario have an end state, but there can be. You denote the end state by drawing a big black dot and a circle around the dot. And the state that pointing to the end state will lead the whole system into a conclusion, right? And we have nasty state. I got an example here. So here is your nasty state. Basically, is a state itself, and we have lots going on within that state, right? And we'll go through some example in just a second. And then you have the transition. Transition basically is the line itself. So when you transit from the open to close, here we draw a line, right? And with an arrow pointing from a state to another, and that's your transition. Events is a label on the transition. We do have a syntax for the events, which we'll cover in just a bit. Any questions for our three main components for a state machine? No? Okay. We have some important properties that we need to know for a state machine. The last two is much more important than the previous two, right? Let's go through them briefly. So the first one is called completeness. Means the system need to be complete. And what does that mean? Means you want to model all the behavior within the system. It's actually you want to include every event, every transition, and every state mentioned in the scenario in the case study, right? If you include every scenario, every state and every transition, basically your diagram is complete. And reachability means there shouldn't be a floating state in your diagram. So there shouldn't be a state sitting there alone without any transition pointing to that state. And that means reachability. From any state in the diagram, from the initial state, by carrying out a predefined sequence of transition, you can reach pretty much any state in the diagram, in the state machine. And that is defined our reachability. The last two is very important. First is called deterministic. Means from a state, if you carry out a transition, you must end in the exactly next state, right? So from state open, if we carry out this transition, then it must end in the next state. You can't have non-deterministic, means we carry out the same transition, then it end up in a different state. And that is not allowed in a state machine. right? If you've done MOC, there's something called the finite state automata, similar idea, right? Like you have the diagram need to be not non-deterministic, means from a state, if you carry out that particular transition, you must end up in the exactly same state, right? You can't go somewhere else. That's true for state machine as well. Okay, and then we have the well-defined. Well-defined have several aspects. The first one is if you do this in the solution space or in the design model kind of space, all the method or all the variable you use, they must be defined before you can use them. And we'll see a concrete example in just a sec. Another thing is for well-defined is your system must have the initial state, and so that's within your nasty state, right? Yeah. Any questions we have so far here? No.
Like one of the common mistake we are seeing is that people tend to have duplicate states, and that's definitely something we want to avoid. So for example, people think about open at the beginning, and then they also have like an open state at the end. This is especially when the state machine diagram become very complex in the question that we often see those patterns that with duplicate state. Yeah, so that's something you really need to avoid.
Yeah, we got an example for what you mentioned just now. Yeah, we'll look at that. Yeah. Any questions? No. So here we have a nasty state and an example, right? One thing to note is within the nasty state, you still need an initial transition. You cannot have a nasty state without any initial transition. That means your state machine is not well defined, and you will definitely lose mark for that. Another thing to note is a minor syntax thing from here is you can have a transition pointing pointing from the superstate or from one state within the superstate. And what's the difference between these two? If we carry out this transition, means from whatever state you are inside this nasty state, you can all carry out this transition, and it will lead you to somewhere else. For this one, if the transition is pointing from one particular state within the superstate, means only that state can carry out that transition, and you go out of the superstate. So if we look at the example here, from bad debt, you can carry out the events that the bank account have been referred to a collection agency, and only from that state you can carry out that transition. But for this one, all standing bill is paid, so pretty much means, well, you're in default. If you pay your bill, then you'll be fine, right? So it doesn't matter which state you are in, you can always carry out this transition, and you end up back in active. Okay, any questions?
You explain how I decide when I want to have a nested state.
How can you decide when you have a nasty state?
When should I?
Maybe we'll look at that in the question. Okay, yeah. We have some more syntax here. For a event on the transition, you have this trigger, a guard, and an action. So trigger is compulsory. Sometimes trigger is the event itself. Every event must have a trigger, and you can optionally have the guard. Guard means a condition that must be satisfied before you can carry out that transition. And you can optionally have an action. You can perform an action while you're transferring to the next state. Okay, really easy, really intuitive. Here we have something so-called a choice pseudo state, and we have one here, option 1 and option 2. These two are equivalents, right? So it's by drawing this diamond shape, it means the same thing as you draw this one, right? So if you cannot figure out how to draw the diamond syntax, just use option 1, right? Here you have the same trigger that is enter a pin, and you have a different guards. One for pin is correct, and the other one for pin is incorrect. Now here we don't have non-deterministic, because even if you have the same trigger, you have different guards, right? The trigger and the guard, these two together determine where the transition is going to go, right? So here enter the pin, And after you enter the pin is correct, then you go to selecting a transaction. If the pin is not correct, you go to calling the police, right? So here you have a deterministic behavior by combining the trigger and the guard. Okay. Another thing to note here is you cannot chain this diamond shape. So we cannot go, we put a diamond here and we chain another one. That is not allowed. Okay. And why is that? The reason is we only have one trigger here. If you chain another diamond, where is the trigger going to be? Right? So there will not be trigger on your events, and that is not allowed.
And just want to quickly add on top of the state machine. So with the state machine diagram, I think it's probably not a very difficult one. So like even with no knowledge of this notation, you will be able to write down something for this diagram. Yeah, so that's why it's really important when you join the events to follow that trigger guard action. So that makes sure you gain all the marks you need. Okay. And then another thing is if you're uncertain about option 2, like using that little diamond there, you can just simply go with option 1. There's nothing wrong with it because we see people making a lot of mistakes when trying to use the option 2.
Yeah.
Okay. So and then spend some time to understand practice that trigger guard action location. So even there's no action or guard, it's nice to have a little slash there. So it reminds you that you always need to have the trigger. But with the slash, you're saying, okay, I've considered guard, I've considered action, but it's not applied in this case. Yeah.
Yeah.
But it's always good to follow that location. Okay.
Yeah. And we've seen many times that people chaining those choice pseudo state, and make sure you don't do that. All right. So here we got a question from exam can't remember which year, but we got an exam question here. Give you guys maybe 5 minutes to read through it, and we'll go through the answer.
Please go ahead.
Okay, okay. At any stage. At least they don't have a question to which one was. Which one?
No, I didn't, it's not very good. The thing that we follow is the process, not the monitor thing. So we monitor the process, I believe. It's like, I can monitor both caches. Then it's like, this is the file, right? The double is greater than the max level, it's greater than the max level that you come up with the fire. And then you this happens until you reach the state where the monitor is. The level is maximum in this upper control, that's the state, because that's the point of time.
And that's what that.
Yeah, and it's the same for the kids.
Good.
Okay.
Struggles with it. Outside and. So, you, something from that, yes,
Okay, this can be one thing, so this match is this is why this is that. The other one is the over the case where over the. We know that over the because we're monitoring Wait, no, he is monitoring the temperature, so it's like.
The overshoot to go from those. Like. And so you go to the final stage of the pump side of the pump to stay.
This is like water. So it's only after we pump the water. So only after this thing we can check if it's overheating.
When the pump is right, you track it, but it's still.
Oh, I see. So because the pump is running over here. I.
For people that are online, you can do a screenshot because we're gonna switch to whiteboard.
Okay, it's really. Sorry. Yeah, that's okay.
Alright, let's do this together, alright? So here, first we have the mine pump system is designed simply maintain the water level in line. Zero, how are you gonna pronounce that? The system monitor regular updates on the current system monitor, regular updates on the current water level. Updates, okay, so I imagine if the water level is detected drop or detected rise. So, we imagine they're gonna be a state of idle. When the pump is not working, right? And then, how we're gonna transit into this idle state? You have an initial transition, and this will be something like start the monitor, start the monitor. And then the system on regular update on current. And then you have the system will monitor regular updates on the current water level, and this is updates here, dot updates. And the level. Right. So that's our trigger. And then it can either go.
I'll go back for you.
Yeah. Then we can either go, let's say, below or above. So here and have a first. We want to define the current level here. Current level. And if the current level is below the minimum level, here we're below the minimum level, then you can transfer, if you want to say, here, it's all dark, you can put it in the square bracket. And you're gonna pump in, so here you have a slash of the action, pump in. Pump in. Here you have another guard, for this, transition. That is the current level. Is greater than the max level. That's guard, and you have a action of the policy. No, this will lead the pump into another state. We can do something like this. Right? So you have a pump running, but this is pumping in, and you have a pumping out. Or we're gonna do something else, is you have a rod state. Right, pump is running. The question is, does this make the state machine non-deterministic? So let's imagine if we only have one state here. And you have current level update, that's the trigger, and you have different start and different action. And these two transitions, these two transitions lead to the same state. And does this make the state machine non-deterministic? The answer is no. What is non-deterministic means if you carry out this transition, then you end up somewhere else. But it doesn't mean that multiple transition cannot transit into the same state. And so you can still have multiple transition transit into the same state. Okay, so we can do something like this. So just have one state here called ready. Pump ready. And instead of having two separate states, pump in and pump out. That pump ready. And we know the pump is pumping in or out by looking at the action here. We have pump in action, pump out. Action, right? And then when is the pump gonna stop is if the pump is running and the level reach minimum level plus lower threshold. Here you can transit back to our idle state by having a guard that is updated, so you could monitor the level of your pump, current level, and our guard will be the current level is greater or equal to any level plus low threshold. Threshold. Right, and also that. And here you have the action of stop. Stop. And we have the same logic here for transitioning back to idle. So you have another transition here. Same trigger, but different guards. And here you will have, I'm just do not put it here. So here is the current level. Until it can reach, here will be current level smaller to max level plus the upper section. Right, and here you have the same action to stop. Right. But by using a single state, right, you simplify. Right, you simplify using machine by transiting into multiple states. And they have you know whether to transit back to the idle by looking at the dark. By looking at the dark. Okay. And then we have our next when the pump is running, it may overheat it. Here you have this overheating. When it's overheated, it will suspend the pumping for a period of 2 seconds. So here you have cool down. Here the pump stop pumping, and it will cool down. Here we need a action that is start the timer. Start the timer. And we can transit back when the timer reach the limit. So you have to cool down and pump running. Yep.
Sorry, we just had a question from Zoom.
Yes.
Could we also model the pumping in and out as individual states instead of actions to make it easier?
Yes, you can definitely. But the problem is if you have that as separate state, then from in the pumping in and pumping out, they need to be able to translate to cool down.
Right, so it just adds a bit of action.
Yes, yes.
Okay. Okay, yeah, thank you.
And we got our last step here at any stage. Right, so at any stage, if we detect a gas leak, here we can have a nasty state. Because at any of this stage, you can transit to another state called shutdown. Shutdown. You detect a gas leak. Detected. And if we receive a safe restart, we'll go back to our nasty state. Here we are missing a initial transition outside the nasty state. So here we're gonna have our initial transition here. And when you reach inside the nasty state, we start from here as well. We need the start monitor here as well. Start monitor. If we have this as two separate state, then it's draw two separate circle, and they have their own transition as well, but they each they need to transit into the cooldown state by detecting overheats. Let me see if we got any questions. Question. But we would also modeling the whole idle pumping in or as running. And we can have individual, yeah.
Ask the question.
Let's move on, guess. Yes.
Hey. Oops. Wait. Okay, let's just move on. I think that's the end of our 5 key diagram, and then we'll just give it a little summary. So we've got the domain design class diagram. Remember, the domain is labeled association. We're looking at multiplicity. We can have inheritance, and please know software concepts. And then for the design class diagram, it's labeled in directed associations, multiplicity, optional dependency, which is the composition and aggregation. We also have the visibility modifiers, data type methods, some class indicators like abstract. And then for the sequence diagram, we've got the system sequence and design sequence. This is one of the typical diagrams that people tend to mix up. So make sure you are aware of the difference. With the SSD, it's the actor. So always start with a human figure. We have system just as a black box, and then we have the message between actor and the system, but not between actor and actors. And then for the design sequence diagram, we always start with a trigger call, no human figure here. And then we've got different object classes because we dive into the system, and then we have method calls. And then for the state machine, you need to understand the start and nested states. You always start with an initial call, and your events should follow the trigger, guard, action, location. And then very lastly, if you want to, you can choose to the choice pseudo state. Okay, so that's what you should know after this. And then we also strongly recommend you to be familiar with the notation for all the diagrams. Be aware of the difference between all the diagrams and the correct notation, because that's the key to gain the marks. And then the best resources that we recommend is actually just available in LMS module. There's UML notation reference. That's where you should refer to. So I do recommend you to go over this before the exam. Now, let's continue with the part 3, which is our design patterns. So we'll start with the grasper principles. So with the grasper principles, we've actually got 9 principles, and I'd like to divide it into 1, 2, 3, 4, 5 little groups with different design focus. And then I'll put the ones, 2 similar ones together for comparison. Yeah, so the first design focus will be the responsibility assignment. So that will be with the information expert and creator principle. And then with the design quality, we've got the low coupling and high cohesion. And then for the behavior control, we've got the controller, we've got the polymorphism. And then for decoupling, we've got indirection and pure fabrication. And then lastly, we've got the stability and flexibility with the protected variation. Let's start from the first one. So for the information expert and the creator, it's all about the responsibility assignment. So the question you ask yourself is who should do what? So which class should be responsible for what responsibility? With the information expert, if you follow that rule, it will be assigned the responsibility to the class that has the required information to perform it. However, with the creator, it's assigned the object creation to the class that's closely uses, aggregates, or contains the created object. So sometimes these 2 rules can be against each other. So, but there's nothing wrong, if you go with first one or the second one, as long as you justify your choice, that should be fine. There's no such a perfect solution for that. You are allowed to have different designs. Okay. And then the next thing we want to discuss about is the low coupling and the high cohesion. So that's all about the design quality. So the question you got to ask yourself is what makes a good design? Does the lowest coupling makes the best design, or the highest cohesion make the best design? So let's have a look at the low coupling. So it's reduced dependency between classes for flexibility and code reuse. However, if you look at the diagram on the left-hand side, we have our auto manager and we have different methods all in this one class. So if we think about the lowest coupling we could have, which will be in this situation, we have one class, single class, as our God class, and it handles everything. And then you have absolutely lowest coupling because you only have one class. There's no coupling you have with any other classes. But is that a good design? Definitely no, right? Because you're letting one class handling too much responsibility, although it has the lowest coupling, but it's definitely not the ideal design choice you want to make. And then the second one we will look at is the high cohesion. So it's about keep each class focused on a small and related set of responsibilities. So in the extreme scenario, which is on the diagram on the right-hand side, you can see that we have one method in each class. Is that focus enough? For sure, because one class only have one method and one responsibility. It definitely reached the highest cohesion. But is that the like best design we want? Because we could have like 200 of classes with our big system, and then that's like you reach the highest cohesion, but with the highest coupling as well. So the design quality is really about finding the balance between the cohesion and coupling. So it's kind of against each other, but you want to find a balance point when you do the design. Okay. Cool. And next is the behavioral control, which is the controller and polymorphism. So for the behavioral control, one question you ask yourself is how should the system control and organize objects? So with the controller, it receives system events and delegates work to other objects. But please be aware for the system events we discuss here, it's not about the business logic. It's more about, it's not like, when certain things happen, this game, this, actor should do this or that. It's about the like, more about the user input, like keyboard or mouse. It's about those system events. And I think most people tend to get that mix. So it's not the business logic, it's more of the system events like, user inputs. Okay. And then the next one we'll talk about is the polymorphism. So it uses a common interface or abstract class to handle the variation in behavior across different object types. It can be the you have the diagrams on the right-hand side below. So you can have the abstract class like the shape, and then you let the rectangle or circle inheritance from it, or you have the interface, with the dash lines. You just have the methods. So these are the ways of polymorphism. So if you're talking about polymorphism, and if I see no interface or abstract class, you probably discuss about something else. Okay. And then the next two we want to discuss about is the prefabrication and the indirection. So both of these patterns helps with decoupling. So this is about how can we reduce the direct dependency between classes. So with prefabrication, it's straightforward. It's create a non-domain class when needed to maintain low coupling and high cohesion. So a very classic example will be a logger class. So for example, if you have a game, and then probably many classes will need the logger because, for example, if a player did something, you want that to give you a logger output, and then a player B do that, you want a player output if there's dice going on, anything that you want to output, you need the logger. So, but you don't want each class to have a such method, so you create a dedicated class called logger, and that handles that responsibility for you. And then next will be the indirection. It's about using an intermediary object to mitigate communication and reduce direct dependency. So if you have a look at this diagram, I think it's directly from the lecture. So you could have like, dependent element with the questionable element. Now you add a indirection element. So like a class in between to avoid the direct dependency. So that will be the indirection. Okay. And then the very last one we want to talk about is the protected variation. So it's about the stability and flexibility. It's about how do we design for changes, because it's most of the time when you design software, there's always some part of the system that's always likely to change. But you don't want to change your code that constant. So you want to, or like, fix bugs because it changed. So you want to do something to protect against change by isolating the variability behind the stable interface or all the abstractions. Okay. Yeah. So with the grasp principle, like if you look at this diagram here, I think what we want to emphasize is on the very top, we've got the protected variation, low coupling, and high cohesion. So these are the ultimate goals that we want to reach with the grasp principle, and everything below that, like polymorphism, indirection, prefabrication, information expert, controller, operator, it's like combining together to to hit that target you want, to achieve the low coupling, to achieve the high cohesion and the protected variations. Okay, so in the exam, if you do get like some questions that wanted you to justify how to use this grasper principle, I think it's important you need to be specific and explain the impact. So for example, don't just state like high coupling. Name the actual classes that is involved with this coupling. So class A and class B and class C, they are all coupled together. And then we can apply such principle to reduce the coupling. So why it matters. And then don't just say a class is an expert. You need to explain what it knows. So for example, what attributes it has that's necessary for this responsibility you're doing. Okay. And then always justify your answers and its effect on the design quality, which is like, the low coupling and high cohesion. That's something you can always talk about, because no matter what design choice you make, you can always discuss about that. Is there anything you want to add up? Oh, yeah. So that's all about the grasper principle. It's just a quick review. You probably won't get a lot of questions on this, but it's necessary for you to understand it, so we can we are able to continue with the later design patterns like Gang 04 patterns. Yeah, so we have our exam question here. It's just a multiple choice. So you could have a look on that and then give it a go. So usually you will get a bit of like grasp principle questions in the multiple choice. And then if you're familiar enough with these patterns, you should be able to do it really quickly. Yes. Perfect. Yay. That's good. So with this question, which grasp pattern promotes high cohesion, low coupling by assigning responsibility? I probably ignore that until I reach handling a particular set of user inputs to our single class. So that's the key point. That's why it's important. So user inputs, the first thing we think of is the controller pattern. So, do we?
Maybe I'll.
It's a client interface because the controller uses the UI.
Yes.
Yes.
So when we talk about controller, it always handle the inputs from the UI. 99% of cases it will be from a view, and view can be a UI or some other events, but like from user. It will be mainly user inputs. And controller sit between the UI layer and your business logic layer. And you may always see controller come used together with the facade pattern and the singleton pattern, because
controller is just one single class that delegate the responsibility. So by most cases, you can create it as a singleton because you only need one single instance. And we'll talk about the facade in just a sec. Yeah.
Now, we are going to our second part, Game of Four. I'll just let Harry do
Yeah.
the rest.
Yeah, sure. So for this section, mainly we've covered, or really just three main categories. First is called the creational, the structural, and behavioral. Right? We've covered about 3 to 4 patterns for each of this category. For creational, the idea is really simple. All the pattern here, they handle how to create objects. So whenever you want to instantiate or initialize an object or create a new instance for something, for a class in your system, you can refer to one of the creational patterns. It tells you how to create instance of class. And you have let's maybe look at the content here. And you have the structural pattern. The structural pattern tell you how to organize your code. Right? So the idea is you have a you have a really large system, right? And how to create new classes and when to use different classes to compose into a really large and complex system, and that's your structural your structural pattern. And we have something so-called a behavioral pattern, and this tells you how different classes communicate with each other. So when you have some sort of flow, like logic flow, when something publish an event, and how does other class respond to that event, you have kind of flow. And you have a behavioral pattern. It tells you how different classes communicate with each other, right? So we have this 3 main category. Each of them have about 3 to 4 patterns, and we're gonna go through them one by one, right? The first one is called singleton. Really simple idea. Singleton is just saying you want to keep one instance of this class across the entire runtime of a program, right? You don't need to worry about like the multi-threading or multi-process. It doesn't involve in this subject, but the idea is you want to keep a single instance of this class across the entire runtime of a program. And here we have a class called singleton, or it can be really anything else, my class, or a logger, or a clock. Right? A clock is a really good example because you want to be able to query a clock class and get a time, get a unified time, right? So you don't want a different class with a different instance of a clock and they're getting different time. So you can create a clock as a singleton. And now how do you achieve this? The idea is really simple, right? You have first a private constructor. By having a private constructor, you make sure no class can call the constructor of this class, meaning you can only call the constructor or create instance of this class within the class itself, okay? And we have a static method called getInstance. If you look at the code, how this is implemented, we have a instance, right? That only single instance is stored in the class itself. And if the instance has not been established, then you call the constructor. If it has been created, then you just return that instance, as simple as that. But by implement this way, you make sure you have only one single instance for this class. Singleton itself is really simple, and you always see singleton apply with other pattern together. One example we've just seen right now, right? So the controller. By applying the controller principle, essentially you are making some sort of a facade pattern, and that can be a singleton. We're going to cover factory in just a sec, right? A concrete factory. You create a single class, one single class that is a concrete factory, have the responsibility to create instances of other classes, and this can be a singleton as well, because you don't need that many singleton. You don't need that many instances to create different instances, right? We can have a singleton to do that, right? Any questions? Any questions? No? Okay. Next, we have the factory. The idea for factory is simple as well. You just create one single class called a factory. So here we have an example. You have image. There may be different images. There can be PNG image, can be IPAC or JPEG. Yeah. How do you create different images? Or if you apply adapter pattern or strategy, you have many classes going on. And who gonna create all those classes? If you don't have a factory, then somewhere in your clients, in the class, in your code, there will be a huge chunk of code to create different instances of all the adapter or all the strategies. Now you don't want to do this. Instead, you extract that code into a single class called a factory, and you handle all the creation logic within that factory class. Okay. The concrete factory is not really a formal pattern defined in Gangnam 4. They have a factory method and a abstract factory, which I have on this page. They don't really have a concrete factory. It is a simplified version of the abstract factory. You don't need to know this, but here we can have a look, right? So here you have a family of different product. Now to handle a family of different product, likely you're gonna need a abstract factory, and you have different implementation to create different family members of that product. Now we don't cover that in depth in this subject. So you just imagine you're gonna create like one single product or a product but different variations. Now you don't need a abstract factory. One concrete factory is good enough to handle that complexity. Okay. Any questions for this part? No? Okay. And then we have the builder pattern. Right, let's maybe go through the definition here. So when a complex object requires step-by-step initialization of many fields and nested objects, then you want to use the builder. The most important thing for builder, the thing that you want to emphasize on is step-by-step. Have I got a so the idea for builder is we want control over the creation steps. Okay, for factory or for singleton or for any other creation node, you don't have control over the steps. So you call a factory, create me this class, and then it will give you an instance of that class, and you don't know what's going on. Like you can't control how the class is created, how the instance is created. But builder lets you do this by, you can take control over the steps, right? If we look at the pattern here, you have a abstract builder, and this builder first will define a set of all the method, and this will all be abstract, and this is a template or a blueprint for what gonna be implemented in the concrete builder. And these are all the steps that we may have to build a car. So you can have different seats, different engine, different blah blah blah, right? You can have different GPS. But the way you build the seats for car, for manual transmission, for a auto transmission, maybe the way you build the engine is different. So we create concrete implementation of that builder, right? And they override this template, the blueprints method. Yeah, how you're gonna use the builder? You have another class. Director is optional, right? So you can ignore that. But if you have the director, first you create a concrete builder, and then this will give you a builder object, and you can go step by step. So builder dot build the seats, builder dot build the engine, builder dot set the GPS or whatever. Right? So you have the control over the steps. Okay, and that's the key difference between our factory and builder, right? For a factory, right? For a builder focus on constructing a complex object step by step, and for a factory is specialized in creating families of related objects. Now you don't need to worry about the abstract factory, right? One similarity is they both can create the same product with different variations. So we can create the image with different image. And this we can create a car, but like different car, the manual transmission or auto transmission. They both can create product for different variations, but the difference is builder emphasize on steps, right? And the factory will just return you the product or the instance immediately after you call the factory. Any questions? No. Any question online? No. Then we're gonna move on to the structural pattern. We have we covered 4 in this semester: the adapter, facade, composite, and decorator. Composite and decorator is probably more confusing than the other. We'll talk about the first 2. Right. The first one is adapter. Adapter utilize the grasp principle protective variation at most, right? So when you think about protective variation, you think about adapter. And when we talk about adapter, immediately you thought it practice the principle of protect variation. Now we have adapter you can call from you can tell from here, right? You have your system and somebody else system. Now you don't want your do I have a diagram? Yeah, you don't want your code, the client class, to call the method from this service class. So imagine I think an example we covered in the workshop is you want to book a flight. So you have different you have like the Expedia and you have different airlines. Now that's maybe your booking class or Expedia class. The idea is this client want to use the service method, right? So this clients want to book a flight from Qantas, and you don't want your client to call this method directly because it will violate the principle of protect variation. What you do is you add one additional layer, and that is our adapter. You have an interface which define the method. So in the client, instead of call this method, you call this method. Okay, you call this one, right? And whatever concrete adapter that will implement this method. So let's imagine you have 4 different airlines. You have Qantas, you have Jetstar, you have different stuff, and they all have their own way of booking a flight. But now you adapt them into your system by defining a unified interface, and what they need to do is they just need to override the method. And within this method, you call the method provided by somebody else. Okay, any questions? No? Okay. And now we have facade. Let's maybe look at the look at here. All right. So the idea for facade, as I mentioned earlier, right? Facade can be implemented as a singleton. Why? Because essentially facade very likely it's going to be a single class, and it handle the complexity of a subsystem. Right? So the whole idea behind facade is it want to hide away the complexity of a subsystem. We got an example here, right? So you have a bank. Right? Yes, can't enlarge. So you have a bank, like a system from like from whatever bank, and you have the ATM. So ATM gonna talk with the APIs. If you don't know APIs, there are port or services provided by somebody else, and you call their services to give you information, right? So that's API. So an ATM gonna use lots of different API by different banks. Now they can't just go into their banking system and call all those different classes and methods because it will be terrible, right? Like it will be so many methods, right? So instead we have a facade act as a a single interface to our banking system. So instead of going to into their system, you go to the facade only, and facade will then delegate, will handle all the complexity within the subsystem. Yeah, so that's the whole idea behind facade. We have on this slide controller versus facade. That's a common confusion, right? So the first thing we need to know, controller is not a pattern. Controller is is sort of a guideline or principle. If you know the MVC pattern, the mode wheel controller is sort of like a principle you want to follow. But facade is a concrete pattern you can implement in your code base. So that's the first difference. The second is controller, right? The purpose of controller is controller sit in between the UI or the view layer and your business logic layer. But facade, the whole idea for facade is it hide away the complexity of your subsystem. Okay, so don't get confused with controller and the facade. But one thing to note here, controller is always implement using the facade pattern. Because if you really think about what controller is trying to do, is controller provide something to the UI, to the view layer, right? And controller delegate all those functions to your system. So controller essentially is acting as a facade. It hide away the complexity of your system and provide a single unified interface to the view, to the UI. So controller is applying the facade pattern. Okay, that's something to note here. Any questions? Sorry, I'm trying to try. I'm rushing through the, yeah. Yeah, if you look at here, I think we covered most of the stuff here. Adapter, let's just skip that one. Right, and then we have decorator. To get the intuition behind decorator is we look at this this example. We have a pizza. A pizza, you have a pizza base, and you have lots of toppings. You have cheese, macaronis. You have onion. You have maybe the sauce or the mushroom. So those are different toppings you can get on top of a pizza base. How you can model this within a software is you use a decorator pattern, aka you have a interface called component, and this will be our pizza. And you have the concrete component or the base component, and this will be pizza base. And you have the decorator, and this is abstract because you can add on lots of different toppings. And here will be pizza toppings. And you have one for onion, one for cheese, one for pepperoni or whatever, right? And you have all this decorator that you can wrap on a base component. Okay. The key thing here is they all implement the same method. So here in the component, you define a method. If that's a pizza, it will be get the price. So pizza base have a price. It will be the price of the dough, right? And you have the toppings. Different toppings have different price. Now you can have like the cheese maybe costs $1. The sauce costs $2, right? So what you're gonna do here is you wrap the decorator on top of a base component, but they all implement the same method. So you call get price, and then it will go through the first layer, get the price of onion, and then go to the next layer, get the price of the sauce, and then go to the next layer, get the price of the cheese, and then you go to the base layer and get the price of the pizza base. Right. So right, that's the whole idea behind decorator. If we read the text here, both concrete class share the option method, and it enables decorator object to polymorphically be used the same way when undecorated. Okay, different behavior though. Yeah. One thing to note here is we have an association, right? We're missing an error, by the way. So there should be an error here, and the multiplicity should be 1, right? Why we have this association? Because here we are storing a component as an attribute, and the type of that component is the component type, is the abstract component. And why we do that? Because you want to wrap on a base, and if you wrap on a base with a decorator, you want to be able to wrap on that again. So you want to be able to put sauce on top of cheese. So here we have this component attribute as a type of the abstract component as the super type. So you can wrap a decorator on top of another decorator, and as the bottom layer is the base component. Okay. Any questions?
Which one is the base?
Hey.
Which one is it?
Which one is
The base.
the base?
Yeah.
This one will be the base. Right, so that's our base, and that's our decorator. Just think the pizza, right? So that's the pizza base, okay, and that's the toppings, okay. Any questions? If no, we're gonna move on. Right? We have our composite pattern here. I like to think composite pattern in two aspects. The first one is what we covered in the subject. That is, we use the composite when you want to operate a collection of atomic objects as operating an individual object. So let's give an example here, right? So we have our Marvel character. Everybody love Marvels. We have our superheroes. Now each of them can maybe can attack somebody. They can do something differently. Now the idea is that's an what's that called, the Avengers, right? The Avengers can attack at the same time. So you want to order an army or a composite or a collection of all those different characters the same way. So you just go the Avengers style attack, and then all this will attack in their own way. Okay, they all have different ways. So how we can model this is by having a composite, right? Again, really similar to a decorator. you have an abstract interface called component, and here you have the what's called the leaf or the atomic objects. So here you have Hulk, you have Spider-Man, you have whatever, right? And you have all these atomic objects. And how you can treat them the same way, how can you treat all of them the same way by having a composite. So here you have a composite, right? If we look at the association here, by the way, here we should have an arrow, and that's a typo here. The multiplicity is from 0 to many. In the decorator, this is 1, right? And here, and here, that's not 1, that's 0 to many, because you store a collection of those components, right? So you treat both a simple object and a complex object the same way. Okay, that's the first aspect of the composite. The second aspect is we can model a tree-like structure, but we're not going to cover this in depth because it's not really mentioned anywhere in the subject. But the idea is, as you can tell right here in the composite, you store a collection of the component type, means it can store itself as well. So you can have a leaf, a composite. Inside the composite, you have leaf, and you have the composite itself, right? And inside that composite, you have you can model a tree-like structure, but we don't need to know that in depth. Here we got an example. Have we? Oh no. Maybe for later, right? And again, the difference between decorator and composite. So on the right-hand side, we have the decorator. And if we pay attention to the association, again, sorry, we're missing a 1 here, right? So here should be a 1. You're storing one single instance of this component type, because for decorator, you only wrap on one object. You don't wrap on many. And AKA the purpose for a decorator is you want to add on additional behavior, or you want to add on additional responsibility to a base object. But here we have association, and here we should have many, right? You store a collection of the component type. You have many here, right? And you're trying to summarize the responsibility of the child components. So once you want to add on additional behavior, and the other one is you're trying to summarize the responsibility from all the leaf, from all the child components. It would be best if you go look at the a website called let me maybe just show you here. Refactor. It would be nice if you guys can go through this website and understand the code, right? So you have this website. I refer to you like many times throughout the semester, and it's a really nice learning resource. For example, you have the composite, right? And it tells you the rationale, the problem is trying to solve, and we then have the pattern itself and a pseudocode. And what's so nice is you have the Java code as well. And be sure you read this section, the relationship with other pattern. This tells you how to differentiate between one pattern to another, so you don't get confused. And if we click on Java, you can read the Java code, and I really recommend you read through the code, right? But because it helps you to solidify the understanding. Yeah, if we don't have questions, we'll move on. That's 5 minutes. Yeah, that's 5 minutes. Yeah. Right. So we have the first behavior pattern called template method. Idea really simple. Basically you're applying inheritance with an abstract class. Okay. Here you define an abstract class. You have an abstract method, like build something, and here you override the method. So that's the whole idea for template method. You're just applying inheritance with an abstract class. And here we got the strategy, which trying to solve similar problem. You have different behaviors, but instead of doing inheritance, you delegate, you move that logic out to another class called like maybe a strategy. An example I always like to give is sorting. So you are building your own data structure, my structure, and there are different ways you can sort your structure. So instead of implementing different algorithms within your class, you have a separate strategy class, and you have a sorting strategy, and you have different concrete way you can sort your structure. Okay. I'll just skip this one for now. And observer, there's nothing much about observer. The key thing here is we want to remember you have the subject or the publisher, and you have the observer or the listener, right? And they all have their concrete implementation. The subject store a collection of the observer, and when an events occur, the subject will go through the list of all the observer and call the method to update them. Okay, that's the observer. And here we do have something that maybe you can go through on your own time, is combine strategy and composite. And that's a very good a very good task for you to complete. And it's like, I mean, if you can get this done, then you will be good, right? And here for the question we got for you is please make sure on your own time you attempt this one. Draw a design sequence diagram for make a new cell that you want to pick the best price for a customer, right? I'll repeat that again. Make a new cell and you want to find a price that is best for the customer. Draw a design sequence diagram for this scenario. And this will combine first the strategy, second the composite, third the factory, and last singleton. Right? So you will cover all those on a design sequence diagram.
Do you want me to continue with this?
Yeah, sure.
Okay, we'll just really quickly go through the architectural analysis. I won't probably spend too much time on this. So I just wanted to quickly remind you all there's two important things. One is the architectural factor table, and the other one is the technical memo. So we won't spend too much time on these. Just in your own time, try to go through this. It's probably good to have these somewhere in your cheat sheet, so you can try to apply it. At least you know what it's about, because it has appeared before in the final exams. Because of time, we probably won't go through this, but remember these two documents, and then copy it in your cheat sheet, so you have something to reference to in your exam. Okay, so here we're gonna wrap up on the final exam tips. And so with the final exam, I think these are the things you're supposed to cover or know about before the exam. And then we do have 3 tips for you. First thing is write what you forget most in the cheat sheet. So you do have a cheat sheet, so write down what you forget the most thing. And then second thing is, if you can, try use a pencil to draw all your diagrams, and then keep your diagrams neat and simple, because if your diagram looks very complex, it's very difficult for you to get the marks. And then the very last thing is to manage your time wisely. Don't get stuck on one diagram. And one thing you remember is you don't have to draw your diagram perfectly. So don't think about you're trying to get cover everything in the question, but just cover the important point, and that's good enough. And I think that's everything from us today. And I was wishing you guys good luck on your final exams.
Thank you so much, Ashley and Harry, for providing a really extensive set of overview of S&D. And for anyone who's interested, these slides will be available publicly after the recording is finished and finalized. So the final few things in architectural tables and architectural analysis can totally be reviewed then at your own time. And there's a lot of content there, so maybe that's better off. Thanks everyone for attending the CISA revision workshop series. If you're ever interested in being a part of more events like this, we do have our CISA link tree just over there. That'll give you access to the revision workshop recordings and slides, but also give you access to membership. And basically, once you become a member, you get access to our calendar, newsletter, stay up to date on every event that's happening for the rest of the year. Lovely. Also, we'd really appreciate if you guys could give this a quick scan and update, give us a response in the feedback form. But in case you rush for time, you can do that whenever you access the slides. Appreciate it. Thanks, guys. All right. I think just the meeting. Yeah, should be good.
Yeah. I'll just stop sharing. I'll just stop now.
Amazing.